Okay, Doppler effect. Like I said, we just need to understand the formula. So we have three formulas. How can we apply this formula? And in which situations can you apply it, right? That's really the question here. So this formula is when you are fixed, like right here. You are not moving. The object that is making the sound is moving. So in this case, in this example, I have a car moving and it's approaching you and is making a sound, right? Or it can be like this to the right. We can see that the car is moving away from you. So those are the two situations that you can have right here. So how can I apply that formula? That's really the question. F sub L will be the frequency that you will hear, right? That you are the listener right here. So that's the formula. That's what the formula will give you, the frequency that you will hear. And right here I have V, capital V in the numerator and also in the denominator. You can see it right here. What is that V? That V is just a number, and is this number right here, is this number 343 meters per second. So it's fixed, is this number right here. That's the velocity of sound. It's V right here, but you just need to change it. And F sub S, that will be the frequency of the source. That will be in hertz. So it's this right here. That's the frequency that the object is making, right? In this case, it's a car, so the frequency will be hertz. And if you don't have those units, you need to change it. The same with this right here. What is V sub S? V sub S will be the velocity of that object, the velocity of the source. In this case, again, it's a car. So what's the velocity of that car? So you need to know that, and it should be meters per second. You need to be careful with that because maybe they give you velocity in kilometers per hour, right? For example. And then you need to change it to meters per second. If you're not aware of that and you plug kilometers per hour right here, it will be wrong. Right? So remember that velocity should be meters per second, just like this one, like the velocity of sound, meters per second. So that's the idea of this formula. But as we can see right here, we have a positive and negative sign. We need to choose one of those two. But you will do it with this. Just follow this sentence right here. Right here, it says positive. It will be positive sign if the source is moving away from the listener. So it's like this situation right here to the right. The car is moving away from the listener. So you will choose the positive sign down here. It's just one of the two. Now, it will be negative if the source, in this case the car, is approaching you, the listener. So now you know how to choose the sign. Positive when the car is moving away, and negative when the car is approaching you. So that's the first formula. Now the second one, the idea now is different. The car is not moving. The car is fixed, is parked. It's making a sound, but you are the one moving now. So if you are moving and you are approaching the car, or you are moving and moving away from the car, you will have to do different things. And actually the formula is different also. You can see right here. It doesn't look like this one. It's the other way now, right? But the values are the same. Capital V is the speed of sound. 343 meters per second is the same value. F sub S, that's the frequency of the source. So in this case, the car, what's the frequency of the source? It will be in hertz. That's the units, right? So you need to check that the units are correct. And V sub L, that's the velocity of the listener, because now you're moving. Before, you can see it was V sub S, the velocity of the source, because the source was moving. The object that was making the sound was moving. But now you are moving. The listener is moving now, so you need to know that velocity. So you need to know the velocity of this person right here moving, right? And you will plug the values right there. But like before, we need to know the positive or negative sign right here. We need to choose one of those two. But it's really easy again. We just need to read this sentence. It will be positive sign if the listener is approaching the source. So like this, to the left right here in the picture, you can see that the runner is approaching the source. He's running towards the car. So that will be a positive sign. But if you are moving away, like right here to the right of the picture, then you will use the negative sign. Now you know what to do with this formula. You know how to apply this formula now. Okay, so those two formulas are, in a sense, easy to apply. This one is the one that is complicated because now both are moving. Imagine that now you are running, like in this situation, but the car is also moving. So both the source that is making the sound and you that are listening are moving. So that situation is the complicated one. So we have two negative and positive signs in the numerator, and in the denominator right here, we have the velocity of the listener, we have the velocity of the source. So we have a lot of information that we need, right? But again, everything should be in meters per second. That velocity should be meters per second. The frequency should be hertz, and that's all right there for the data, let's say. But now for the positive and negative signs, you need to read right here. You can see right here at the bottom, it says numerator. So numerator, it will be with this right here. It will be positive when the listener is approaching the source. So you will take the positive sign up here, because this is the numerator, when the listener is approaching the source, when you're running towards the source that is making the sound. Or it will be negative if you're moving away from the source. Okay? That will be the sign for the numerator. You will choose in that way. Now, in the denominator, you have to do this. It will be positive if the source, because remember that the source is moving also. So the source is moving away from you, from the listener. So right here, you will choose the positive sign when the source is moving away from you. Or you will choose the negative sign when the source is approaching the listener. So that's why I said this is the complicated one, a lot of things right here. But you need to just read these sentences and you will understand depending on the example. So I have an example right here to fully understand the formulas. Now we understand them in a sense, but it was abstract with, without numbers. But now we have numbers right here with this example. So we have a person is just standing. This person is not moving, it's motionless. It says right there. And the vehicle is moving 90 kilometers per hour. Right? So it's like this situation. We can go back to this first one. You are standing, the person is not moving, it's just listening, and the car is passing by. Okay, so that's the situation. I know is this formula. Okay? It will be this formula. So I go back to the example, and they are giving me the frequency of the sound. The car is just making a sound with this value right here, 500 hertz. So that's the correct units, right? So that's the correct value. I have it right here. You don't need to change it. It's correct. But the other one, the other data that is given is this. That's the velocity of the source. That's actually wrong in a sense because we don't have the correct units. We need to change it. So I need to use this one, meters per second. It's the same. You can change 90 kilometers per hour and it will give you 25 meters per second. I'm not doing it right here because you're supposed to know how to do it already. So I skipped that part. So that's the velocity that I'm going to use, 25 meters per second. And also this one, the velocity of sound, but that one is a given value. That's fixed, 343 meters per second. So I have everything. I just need to apply the formula. But you can see down here, I have two situations. I have this formula right here with a negative sign, and then I have this with a positive sign. What happened right there? Right here, they are asking what's the frequency when the car approaches. So it's the same formula, but the car is approaching you. So if we go back to the picture, the car is approaching you, it will be this situation. It will be the one to the left right here. So I need to use the negative sign down here. So if you see right here my example, we have a negative sign in the denominator. I choose the negative sign. Everything else, just plug the values, and that's it. You find this on your calculator. 539.3 hertz. That's A, because the car is approaching. Now B, it says when the car moves away from you. So we can go to the picture again. and we have this equation to the right, the vehicle is moving away from you. So you need the positive sign. So it's the same formula. It's the same formula down here on B, but I need to choose the positive sign, and that's what I did. You can see it in the denominator right there, it's positive. And that's the value, 466 hertz. And that's it. It's the same formula, but you need to understand when to apply the negative sign or when to choose the positive sign. That's all that you need to do. Okay, and like I said, I have an exercise, but I'm not going to give you the exercise because I don't want to give you extra work, right? So we have finished with this, just with the example. Now I'm going to take the attendance.